Hello everybody, this is Chemistry at Glance and my name is Aneta. If you don't know me yet, I'm a student and from my channel and also my blog page, where I will link in the description box below, I try to help people with the A-level chemistry course. On this channel, you'll find past paper questions for every single topic there is in AS level chemistry, and on my blog you'll find all the tutorials and all the explanation, the theory behind every topic. And this movie is starting a series on my YouTube channel. I'm gonna do short revision clips, and today we're starting with all the organic equations you have to know, remember, know how to write, know how to work with for your AS level exam. So we are starting with the combustion of alkanes. It's one of the first topics in your organic chemistry. And here at the beginning, we have two types of combustions of alkanes. One of them is a complete combustion, and one of them is the incomplete combustion. The difference between those two is during the complete combustion, we have an excess of oxygen. So whatever the amount of oxygen we need, it is provided in the equation. So we have much bigger amount of oxygen than we actually need. In incomplete combustion, we have not enough oxygen to complete the reaction. Therefore, in a complete combustion, we produce carbon dioxide, and incomplete, we produce carbon monoxide. Excess oxygen, so we have more oxygen, so carbon dioxide. Not enough oxygen, so we have carbon monoxide. Of course, as you know, both of them are pollutants. Carbon dioxide is a greenhouse gas, so it's bad for us. However, carbon monoxide is also toxic, and it's even worse than carbon dioxide. Therefore, it's much better to form carbon dioxide, which we learn how to get rid of, than producing carbon monoxide, which is toxic for people. So I'm going to start off with an equation, and this equation is going to be the combustion of propane. We add oxygen, and every time we have a combustion, the only two products that we're going to get is carbon dioxide or carbon monoxide in incomplete combustion, and water. These are the only two products. This equation always looks the same apart from the alkane we're using. The alkane will change, oxygen will always be there, carbon dioxide formed, and water formed, if we're speaking about the complete combustion. Now, as you can probably see, we have 3 carbons on the left-hand side and 1 carbon on the right-hand side. So the next thing we gotta do is balance the equation. I always write all the elements on the left-hand side and all the elements on the right-hand side. They're gonna be both the same, and I count the initial number of each of them on both sides. So we have 3 carbons on this side, 8 hydrogens and 2 oxygens. On this side, we have only 1 carbon, we have 2 hydrogens, and we have 3 oxygens. So the next thing you want to do is try to balance them. I'll start off with the carbons. So I have 3 carbons on the left-hand side, so to get 3 carbons on this side, I'm going to put a 3 in front of the carbon. So straight away we get 3 carbons. However, that also changed our number of oxygens. We now have 7 oxygens. Still not equal. Okay, next I'm going to move on to hydrogens. We have 8 hydrogens here. We have only 2 on this side. So to make it equal, I'm going to put a 4 in front of the water. 2 times 4 is 8. They both equal. But again, number of oxygen is already changed here. We have 4 oxygens, because we have 4 in the front, plus our 6 oxygens on carbon dioxide. So together we get 10 oxygens. To make it equal, I'm just going to put a 5 in front of our oxygens here. And now all of the elements are equal. Therefore, our reaction is balanced. And this is an equation for a balanced, complete combustion of alkanes. You might be asked to write this type of equation or just balance it, but whichever question you get, you're always gonna have these three things being exactly the same as on this one. It's only gonna be the alkane changed, and then you have to balance it depending on what alkane you'll get. Next, we have an incomplete combustion. We'll use the same alkane. We're gonna use propane. We add the oxygen, exactly like in this one. However, our products are going to be carbon monoxide instead of carbon dioxide, plus water. Water stays the same. Again, we need to balance it. As you probably realize, the balance numbers won't be the same because we have one less oxygen on the right hand side in this incomplete combustion. Therefore, we have 3 carbons, we still have 8 hydrogens, and we have 2 oxygens. On this side, we have still 1 carbon, we still have 2 hydrogens, however, we also have 2 oxygens. So first thing that's not balanced is the number of carbons. So again, I'll put a 3 instead of in front of the carbon monoxide. That makes 3 carbons, but it also changes the number of oxygens. We have 1, 2, 3, 4 oxygens. That's not equal. Let's move on to hydrogens. We have 8 on this side, so we need 8 on this side. So we got 8 hydrogens. So hydrogens and carbons are balanced. But now we have 4 plus 3 is 7 oxygens. Therefore, to balance it off, we have to put 3.5. That makes 7 oxygens. The only time you put a 3.5 or half in your equation to balance it is when you're doing the combustion of alkanes. If you get any other equation where you have to balance it, you never put a half in. You always put a whole number. During combustions, that's the only time you can use a half in your balancing. Okay, so these were the basics of combustion of alkanes. I don't think you need to know anything more apart from this. You just have to know there is a complete combustion, there's an incomplete combustion, and what goes with which one. Thank you very much for watching. Remember to like, subscribe, and see you soon. Bye bye.